Okay, probability and independent events. I want to talk about this idea. It's not really super difficult. Some of the notation is a little bit weird, so let's talk about the notation first and then do a really quick example, and hopefully we can make some sense out of this. So we want the probability of A and B and C. And what we're assuming here is that they're dependent events, and that we're not going to have the pieces will not be put back after they've been drawn out. Let's see if I can make sense of that in a second. So hang with me. So if I want the probability of A, B, and C, what it is the probability of A. That makes enough sense. Times the probability of B, here's the notation, given that A actually occurred, times the probability of C, given the fact that A and B occurred. So there's that notation, and in notation form it looks pretty good. So let's work on this. We have a deck of cards that has 52 cards. So we have 52 cards. It's the standard deck, right? 52 playing cards. Aces through kings, 4 suits, 13 in each set, blah, blah, blah. Just what you expect. And I want to know, well, what's the probability that I am randomly dealt an ace, and an ace? So I'm going to go to the model that's above us and say, well, what's the probability of that first ace? Well, the probability of the first ace is that there's 4 aces in the deck of 52, and there are 52 cards to choose from, so I have a 4 over 52 chance. Now I'm at this place, so just give this a look. So now we're here. So okay, so what's the probability of drawing this ace? It doesn't say which ace it is, but it's another ace. Well, how many aces are left? If we drew one here, then there'd be only 3 aces left, wouldn't there? And there wouldn't be 52 cards left because you drew one of them. I have one of them in my hand, so now there's 51. So this number explains this, the probability of that second ace, given that I drew the first one, right? Now you get to here. The probability of the third ace, given the fact that I already drew an ace and an ace, right? Well, that would be 2, because there are 2 aces left to draw, aren't there? And they're not 52 cards, they're not 51 cards, because I took a card here and a card here, so we're down to 50 cards. And then we'd multiply across here, and we'd get 24 over 132,600. And believe it or not, that does simplify. So the probability of ace, ace, ace is equal to 1 over 5,525. So if somebody draws 3 aces in a row on you, just off the top of a deck, suspicion. All right, if you haven't already subscribed, please do. If you have comments, please make them. Thanks.